What's up, guys? Today we're going to test the velocity on these German surplus rounds. And these were the rounds sent to me by Ryan. So thanks to Ryan, I'm able to make this video today. And if we look at our head stamp, it says P249, S, 16, and 36. So I'm guessing this is 1936 German surplus ammunition. And we'll fire 3 rounds out of each rifle, compare the velocity and accuracy between the two. And we'll be firing through the chronograph into that white paper on the hill over there, which is 100 yards away. Alright, so first up with our German surplus is the Kar 98A. Our first shot came in at 25-26. 25-06. And 24-46. And I think with that last shot it was kind of like a hang fire. So on that last shot I might not have even hit the paper. So here's our accuracy out of the 98A. Only 2 hits on the paper. The third shot, which I know I pulled slightly, must have missed. But this is weird. This time our hits are really high. Whenever I tested accuracy from the 98A before with PPU rounds, every single time they would hit really low and really left. I wouldn't say it was any to the left or right this time, because that was probably just shooter error if anything. So they seem to hit somewhat center, just really high this time. And now the Hugo Mauser. .2503. 25-33. 25-42. Okay, so that time we had 1 hit the center, and then 2 up here. We had 1 just about dead center, and then 2 a little high and right. So I think my sight still is hitting slightly right. If this was my last shot that hit the center here, then I do think for sure that it was just shooter error why these 2 are up here. Because I feel like I took my time more and just sent it more accurately on that last shot. From bottom to top, that's probably about 8 inches. But then we're probably only about 3 to 4 inches from side to side. So I made a chart of these rounds using what I assume is their ballistic coefficient. I read somewhere online that they have a .58 BC, which is actually pretty high. And I also went with the average velocity from the Hugo Mauser to make the chart. So we have a 198 grain bullet at about 25-26 feet per second, which gives us 2805 foot-pounds of energy. And this is with a 100-yard zero and a 7-mile-an-hour wind at 110 degrees. With 90 degrees being a left-hand crosswind. So then at 200 yards we got 4.6 inches of drop and 2,236 feet per second with 2,198 foot-pounds of energy. And with that 7-mile-an-hour wind we get 1.76 inches of drift. And obviously this chart isn't going to be 100% accurate. Regardless if it's 100% accurate or 98%, we still get a pretty accurate general idea of what we can expect from these rounds at different ranges. We might not get exactly 1302 feet per second at 1,000 yards, but it will be pretty close. So it's still pretty cool just to get a general idea of what we can expect from these rounds' performance. But anyways, that's all for this video. Thanks for watching.